Hello, everyone. Good morning. Thanks for joining this session. My name is Manish Jain. So today we are going to talk about this energy monitoring or energy management system. I mean, this will be in level. I mean, first time we'll just discuss what exactly is this energy management system and how does it work, and what are the benefits, and while monitoring this energy system, how we can make best use out of it. And sorry for the delay. So why this energy management system is very important for any industry. I mean, we all know that energy is a fixed cost and it's a variable cost as well. In order to optimize your cost of production as well as reducing impact on the environment, this energy is the first thing, I mean, which we can work easily. And since the cost of energy is getting increased day by day, so So, so now we are going to talk about this IoT-based smart monitoring. I mean, this is a very generic concept. Although it's not just for energy, it's for your factory automation as well as the smart factory. So in the competitive market, I mean, we have to be very smart in terms of manufacturing at the lowest cost, as well as keeping the productivity and the quality at the highest level, so that our customers will be delighted and we can deliver a very good solution. So we all know that I mean, in industry, in a typical manufacturing industry, the energy consumption is majorly into two parts. One is the utility area. The second is the production area. When we are talking about utility area, it consists of your discom energy, I mean, which is coming from distribution company. The second is your auxiliary supplies like DG generators or the gas generators. Third is the UPS. Fourth is nowadays solar. So these are the supply side, and from the utility consumption side, the most uh, important are compressors for compressed air supply, and second is the chillers. I mean, chillers are majorly for hospitality or the hotel industries and commercial buildings. So in this commercial industries or IT industries, these chillers are major energy guzzlers. But this will fall into utility side. The third one is the boilers or the ovens. Which comes into the utility area. And from the production point of view, it is the production machines. I mean, where uh, we know, for example, we have punching machine, we have bending machine, we have CNC cutting machine, and for each job we should know what is the energy consumed in producing one particular or processing one particular job. So this is helpful in understanding the cost of our production in terms of the energy consumption, as well as optimizing it. And if suppose this becomes very important when we have, say, four of similar type of machines, and in one machine the specific energy consumption, by the way, specific energy consumption is the energy consumed by for making a particular job. For example, if I have a bending machine, and like, I mean, in bending machine the energy consumption is made by the hydraulics or the other machines, I mean, machine parts. So we will know that, I mean, by the end of the day, if we have produced 10,000 pieces, and we know how much energy is being consumed, so I mean, we'll know what amount of energy is required for producing one band product. So once we have this energy information, we can optimize it, compare it, with different machines. So if we have say four different manufacturers machine, which is generally the case, like I mean, as industry grows, we start with one manufacturer, then we go for another one, and then we try to modernize it, and more efficient machines will buy it. And but we don't know when we should get rid of the old one. So we keep going on with the old technology, but we don't know the cost of uh, I mean the price which we are paying to maintain that machine. So once we have this specific energy consumption data of each machine, we'll be able to know, like I mean, whether we should go for a new technology or not. So I mean, these are the challenges which everybody knows. I mean, if we become efficient and more greener, it gives us brand a value, as well as a competitive edge against our customers, or I mean, against our competitors, or maybe the future competitors. So if we are already 10 steps ahead, I mean, it will take them to, a while to catch you up. So, and the second part is the productivity. Each machine, how much it is producing, I mean, all the productivity rule, like overall equipment effectiveness, and like, I mean, how much we are wasting in terms of quality, how much when machines are available, like, I mean, for duration of the time for which the machine was available, and what was the major causes of breakdown and all that thing. I mean, I mean, for a smart factory, these things become important. And like, I mean, from the production data, I mean, if we are just getting the real data from the production line, and this data is now, if it is fed to the ERP system, so I mean, it becomes seamless. So I mean, it is like, I mean, as we call it, as in our terms, like shop floor to top floor integration. Because the top floor guys, I mean, they don't know, I mean, what exactly is happening in the shop floor. And the data which goes from the shop floor, it is subject to huge manipulation. Sometimes it's intentional, sometimes it's non-intentional, but the accuracy is always doubtful. And especially in case of energy monitoring system, uh, the accuracy is even more compromised, because the time of the data reading is not, uniform. So if we have, say, 200 machines, if a user starts noting down the energy consumption, it takes, I mean, 30 seconds, say, for from 1 meter. So I mean, 200 machine means, I mean, around 6 hours or 4 hours, whatever. So it consumes a lot of time, and by that time, we will not be able to baseline, like, how much energy is consumed in 24 hours. I mean, because the accuracy is always like 24 or 23 hours or 25 hours. We don't know. So we can't reach to that level. So and at the end of the day, what happens, I mean, it just leads to confronts that, I mean, the maintenance guy, they say that, I mean, we are maintaining it very well, it's the production, I mean, which is not using it efficiently. And I mean, then the decision making is very, very difficult. So the only answer is to automate this data flow. So now coming to this real-time monitoring, where this is, as I said, that this is the answer for all these confronts, or reducing this manual, data feeding, or manipulation, which is done. So this is one of sample dashboard of and how it looks like. If you see, I mean, the in the second part, we are going to show you the real dashboard as well. So we can hold until then. So I can just briefly tell you, like, I mean, for energy as well as for, I mean, all this process parameter, there are two major categories of data. One is the instantaneous data, another is the cumulative data. Now, if I say how much is the power consumed by a machine, this is the instantaneous data, because when machine is running, the power consumption is different. When it is stopped, it is different. But energy consumption is always kind of increased. I mean, if I read the reading of the energy meter, say it is 100 today, tomorrow it will be 200, next time it will be 300. I mean, it will be like added on. So this is a cumulative. Another one is instantaneous parameter. The other example is like if we are measuring the flow of water or flow of air. So this flow of air or flow of the water, that is instantaneous parameter. We will know that, okay, I mean, during peak daytime, the flow of water requirement was say 100 liter per minute, but in the lean time it was 500 liter per minute. That is one thing, I mean, which is very important for understanding the process. But at the end of the day, we will require like how much water is being consumed in the shift. So that is like totalized value of the water. So that is cumulative value. Similar to that, the third parameter is power factor, which is widely misunderstood by many people, that they consider this power factor value from the APFC panel, that instantaneous parameter is like, I mean, this is what the power factor is, which is not the case. I mean, if you are seeing it's 0.99 right now, we don't know, like, I mean, whether this is for all the day or not. In night time, when the load is low, the power factor may or may not be low, or if it is going into the overcompensation or undercompensation, we really don't know. I mean, at the end of the day, we need to know like how much has the power factor has been in the last 12 hours or 24 hours. So that has to be cumulative value. Based on that, we can take decision. And of course, I mean, this is very interesting. As I said about power and flow, uh, I mean, from the analysis point of view, we should know this aggregated value, the cumulative value, and then we can just see, like, I mean, if, for example, our process is designed for consumption of, say, 1,000 liters of water per day, and if we see that, I mean, one certain day, I mean, the consumption of the water was 1,100 liter, and after that, I mean, we have to look into the instantaneous parameter of the flow. So we can pinpoint that, boss, this is the time when the flow of water was more. I mean, what was the reason? Similar to the energy consumption, we can see that, I mean, the energy consumed in a day is that much, and when the energy consumed was more, I mean, was it like, I mean, extra machine, or that a machine requires some kind of lubrication, or the maintenance is due for that machine. So we need to know all that information. So when we are doing any analysis, we will need the cumulative parameter as well as the instantaneous parameter. So this will help in understanding our process and optimizing it in a better way. That is another dashboard view. I mean, these are like, I mean, all the bars are cumulative. I mean, which shows that every half an hour, I mean, what has been the energy consumption. Again, I mean, these two different colors are for different type of energy, I mean, apparent and active energy. And these are this is very important. I mean, I would like to give just 3 minutes for that. This is the maximum demand. It is not useful for all the machines. Rather, it is useful, I mean, very useful when we are talking about our plant's energy consumption. All these commercial metering or the distribution company, they, I mean, when we take an sanction load, where we get a load sanction, that time we say that, I mean, our total load is at 2500 kVA. So what does that mean? Like, I mean, 2500 kVA. So distribution company, what they say is, I mean, okay, you can use up to 2500 kVA, but if you are consuming more, then we're going to penalize you. Now, this is, I mean, if suddenly your load shoots up, it goes to 2700 kVA, will you be penalized for that? No. So what they do is, I mean, they accumulate every half an hour and take average of that, and then that is what the maximum demand, which is calculated. So our system supports all that algorithms to calculate your maximum demand. So in case, this is useful in both the cases. If suppose your plant is facing a problem of having this maximum demand penalty, or if it is having excessive sanction load. So and if you can save by reducing your contract demand, so both things will be very, very useful. So sometimes, because the fixed charges, whether your plant is running or not, we have to pay for the fixed charges. If we can reduce it, or if we have to increase it because of our, or like, if suppose we are seeing that our panel, this maximum demand is crossing, during that time we can just optimize the process, that why this particular time this maximum demand was crossed. So we can see by looking to the history of the maximum demand data. These are the, anyway, that we'll just go through in the real live demo. This is now in power or energy, or this electrical energy monitoring. The other segment, I would say that uh, there are two major aspects. One is rather three. One is the maintenance point of view. Second is the CFOs, or the financial point of view. The third one is the again, maintenance point of view, but this is for power quality. So the kind of power we are getting, we should know the quality of power. This is defined in various ways. One is like, uh, again, this quality of power again factored into two part. One is like from the supplier side, another is from the consumer side. From the supplier side, if the voltage is unbalanced, or the variation of the voltage is very much, so that is something which is in the control of the supplier side. As well as nowadays, this uh, uh, harmonic distortion. Harmonic distortion is also like, from the supplier side. If from external source, if we are getting harmonics, that is also dangerous for our utility. At the same time, from the consumer side, the power, when this quality of power is determined by some internal factors. Again, the harmonic is one. If we have much of switching load, the harmonic will be generated by ourselves. The second is the power factor. If we have low power factor, if we have more of inductive load, we'll have low power factor. As a result, the current of the entire plant will be more. The safety will be compromised because we are running more current in the cables. And the third one is unbalanced load. So typically in some industries, like, if we have single phase loads, or the lighting load unevenly distributed, will come to the unbalanced load, which is, again, we cannot exactly call it as power quality, but it is definitely is not a good way of distribution of the power. So all that information will be very much required. The second part is commercial. That we all know that, if we know what has been the power factor, how much energy is being consumed by each machine, what has been the maximum demand, all that information we can control in both the aspects. This is one small case, like, if we have, say, two compressors. This is just for an example. If we have two compressors, we should know how much energy is being consumed. We know the CFM generated by these compressors. We can find out with this energy monitoring system that how many hours each compressor was run. We can compare the energy consumption, so that we can, if suppose we have new generation compressor, we can just say that, okay, we can optimize our process in a way that this will be done for 75% time, and this will be done for 25% time. Again, so these are the part of kaizens which we do. Like, we may be wasting so much of energy. So by helping by the help of this data, we can make improvement in the process. we can make it optimize and the energy consumption. Like, I mean, we can just design, I mean, without replacing anything. I mean, no capital cost will be involved. Just by changing your process or the timing, we can control many of the things. So once we start getting data, the first use of the data is keep monitoring, keep looking into the data. So once we get used to of this data, we can take action easily. So the best part of the solution which we are proposing is that uh, it gives you all graphical view. Now, for example, this particular graph, I mean, anybody can see that during this time, 8 to 12, 14, 16 hours, I mean, that is 8 to 2 o'clock or 4 o'clock, the energy consumption was increased. So that means that is the time. So if instead of that, I mean, if we had the table of data where this energy consumption for every half an hour was written, we cannot take decision that fast. I mean, it gives you familiarity. We can just see that, I mean, this is how it is getting increased. So it's more visual, and more visual will help you in analyzing very fast and more accurate as well. So this is architecture of how the system is there. Uh, like, we have machines which are connected through, of course, the energy meters, and this will come to the server. And from the server, we have a database server where the data is being stored in the database. Another is the analytical server, which analyzes the data. Now, and it can integrate with certain type of reporting for by email or by SMS. At the same time, the same data can be used for integrating with your ERP system. So that will be part of analytics server. So it gets all the data from the database server, and the main application server is for real-time data viewing, as I just showed, or we are just going to have a demo of that. So that is for real-time view as well as the historical view. Uh, and this analytical server is for analysis of the data. Now, see, the thing is, I mean, in the industry, we have lots and lots of data, but no information. So the idea of this system is not to generate data only. The idea is to generate more and more of the information. The kind of information we can generate, we can make best use of this system. So our part is like, I mean, we analyze the data in a certain way that it can help you on a daily basis, optimizing your process. So again, the reporting, again, I mean, there are multiple channels of report delivery. One is like, we can have like SMS, another is email, and third one could be, I mean, if you want to know, I mean, through certain mobile app, or maybe some kind of nowadays this chatting applications like WeChat or Telegram, or I mean, web app. Sorry, WhatsApp is a bit expensive, so we don't suggest. But there are way by which we can integrate with these apps as well. Slightly different part. Like, I mean, this is the equipment effectiveness model. That also is another way of smart factory automation. Um, like, I mean, it's like, we have this overall equipment effectiveness. This effectiveness of the equipment is determined by availability, productivity, and quality. Now we are going to I mean, integrate this energy as well. So it's a four-way of optimization. So effectiveness is like, uh, this availability of a machine, like, I mean, how much time it was under breakdown, for what time this machine was available to the operator. The second one is like, what is the efficiency of the operator by which he's producing the, I mean, is there any are there any minor breakdowns, or minor stoppages, because of which the productivity is not achieved. The third one is, even operator is efficiently producing, but the quality product is not being produced. So if if you are having low quality product, so that is a concern. So all these things. Now, I mean, what we are in adding it is the energy effectiveness as well. So how much this process is designed for energy consumption, so that can also be integrated with this. Uh, I don't think that, I mean, we need to discuss the benefits. We all know that the benefits are multifold. If we can say increase the power factor of the machines, or the, the utility, I mean, uh, power supply, we can reduce the current consumption, and this reliability of the system. I mean, we all know the commercial aspect. I'm not going into the detail of that. I'm just going to talk about what are the bonuses. I mean, these are the major advantages, but the bonuses are like, I mean, if we have low consumption by our cables, we will have more reliable you know uh, of a reliable system. And at the same time, if we see that, I mean, the harmonic distortion was high, so we can reduce our breakdowns of the failures of the electronic equipment. If the load was unbalanced, definitely it will the neutral current will be more. And I mean, the system reliability or the safety is getting compromised. So we can reduce all the safety, we can increase the safety and the reliability of the plant. So these are the fringe benefit, or indirect benefits, which we are getting by having the energy monitoring system. The third one would be the you know calculating the cost effectively, or I mean, if we have to take decision whether we should go for alternative source, uh, like solar, or I mean, we have this time of day billing, how much production or what all the critical thing which we can move to the lean period where the energy cost is very low. So all that calculation we can do. So and of course, the third one is like, if we have efficient machine, if we have bought new generation machine, everything is there, but is somehow there is some problem in mechanical wear, and because of that energy consumption is increased. So it will give us an indication that, I mean, this has breached its baseline. Energy consumption is getting increased, so we should look into the maintenance part of that. So this accountability and benchmarking is very, very important. Until we know that what are the benchmark for certain machines or the certain process, we cannot control. I mean, it is very highly recommended. That's it for the presentation. So please feel free, if you have any question, please type in the chat box.